I'm R. Prabha, Assistant Professor in the Department of ECE, SNS College of Technology. In this Microwave Engineering lecture series, we are going to see the next topic, S parameters and also the properties of S matrix. So guess the topic. We know that it is the topic is S parameters, and take a two-port network. So two-port network are often considered by the four type of parameters. It is Z, Y, H, and also ABCD, or otherwise called as transmission parameters. So by using these four parameters, usually the two-port networks are described. And there are some of the drawbacks of these Y, Z, and H parameters in microwave engineering and also for analyzing the microwave systems. Because at microwave frequency, total voltage and current are difficult to measure, and ideal open and short circuit terminations are difficult to realize. Active devices of microwave will oscillate under open or short circuit conditions. So these are because of these drawbacks, we cannot use these conventional Y, Z, H parameters to analyze the properties of microwave systems. So we go for other type of parameters called as S parameter or scattering parameter. So now the significance of S parameter is the incident and reflected waves are being monitored instead of measuring the voltage and current, because voltage and current measurement is difficult in the case of microwave. And here the resistive termination is employed. And the third point is active devices are normally quite stable under resistive termination. So by using this, we can easily measure the parameters of microwave devices and the S parameters. So here in the diagram there is a two-port network with four parameters are mentioned here. One is A1, A2, B1, B2. So now based on this, all the S parameters are measured by sending a single frequency signal into the network or blockbacks and detecting that waves exist from each port. So here power, voltage and current can be considered to be in the form of waves traveling in both the directions. So here in the diagram there are two port network, ports 1 and port 2. So here the wave which is incident at port 1 is called incident wave. And in the second diagram we have two type of wave. One is reflected wave and another one is transmitted wave. So when a wave incident on port 1, like in the first diagram, and when it is transmitted, so it is called the transmitted wave. But due to some of the imperfections or due to various reasons, part of the like impedance mismatch, part of the microwave energy will be reflected back, and that wave is called reflected wave. So the incident wave is at port 1, and in the opposite direction to the incident wave there will be a reflected wave because of impedance mismatch or any other reasons. And the transmitted wave is the useful wave which is transmitted from port 1 to port 2 for various applications. And now we are going to see the first S parameter called S11. So here S11 refers to the signal reflected at port 1 for the signal incident at port 1. So S11 parameter is the ratio of two waves. One is B1 and another one is A1. B1 by A1 is equal to S11. Here B represents the signal reflected and A represents the signal incident. Both are at port 1. So this is nothing but the definition for S11. So S11 is the scattering parameter, which is the ratio of the two waves. One is B1 and another one is A1. B1 is the reflected wave at port 1 and A1 is the incident signal at port 1. And next parameter is S21. So here consider the diagram. There is a port 1 and at the other side we have port 2. So we have the incident wave called A1 and transmitted wave is called B2. So here S21 refers to the signal which is existing at port 2 for the signal incident at port 1. So this is S21. So S21 is nothing but the transmitted wave at port 2 because of the incident wave at port 1. So this is scattering parameter S21. So this is the ratio of two waves. One is B2, that is transmitted wave, to A1 is the incident wave at port 1. So other two parameters S22 and S12. So S22 refers to the signal existing at port 2 for an incident signal at port 2, and S22 is the ratio of B2 to A2. B2 is the reflected wave at port 2, B1 is A2 is the incident wave at A2. So B2 is the reflected wave, A2 is the incident wave, both are at port 2. So this is S22. Next is the last parameter S12. So S12 refers to the signal existing at port 1 for the incident signal at port 2. So S12 is the ratio of B1 to A2. So finally, we can conclude a linear network can be characterized by a set of simultaneous equations describe the existing waves from each port in terms of the incident waves. S11 is B1 by A1, S12 is B1 by A2, S21 is B2 by A1, and S22 is B2 by A2. So you can see all the numerator constants are the reflected wave constants B1 and B2, and the denominator constants are the incident wave constants. So here the S parameters in microwave are complex in nature. They have magnitude and also the angle, because both the magnitude and phase of the input signals are changed by the network. So because of this reason, these scattering parameters or S parameters are referred as complex scattering parameters. So we can simply write the scattering parameters in matrix form. B1, B2 is equal to matrix of S11, S12, S21 and S22 multiplied by the A matrix A1 and A2. So here B1 can be represented as in equation form S11A1 plus S12 A2, and B2 is equal to S21 A1 plus S22 A2. So for a multi-port network, consider here there are 5 networks. The matrix can be 5 cross 5 matrix, the S matrix, that is from S11, S12, S13, S14, S15 till it is S55. And B parameters at the left side, B matrix is B1, B2, B3, B4, B5. And at the right side, the scattering matrix is multiplied by the matrix A, that is A1 to A5. So this is for a multi-port network. In this example, we are seeing 5-port network. And as we see already seen already, S11 is the parameter and also called as reflection coefficient, and it is coefficient at port 1 with A2 is equal to 0, and its formula is B1 by A1 when A2 is equal to 0. And S21 is called forward transmission coefficient from port 1 to 2 with A2 is equal to 0. So the formula for S21 is B2 by A1. And similarly, the other two parameters, S12 is called reverse transmission coefficient from port 2 to port 1 with A1 equal to 0, and S22 is nothing but a reflection coefficient at port 2 with A1 is equal to 0. And now we are coming to the properties of S matrix. So the first property, we can see that for M port network, the scattering parameter matrix is always a square matrix with the order M cross M. For example, if we take 3 port network, its order is 3 cross 3. So always scattering matrix is the square matrix. And next property, for a lossless network, S matrix is unitary. So this is unitary property. S matrix and its complex conjugate both are multiplied is equal to unity matrix. And another one is third property, S parameter is symmetric for all reciprocal networks. That is, S matrix is equivalent to the S matrix transpose for the reciprocal networks. That is, we can write Sij is equal to Sji. So the conclusion of this properties of S matrix under the previous two conditions, summation I equal to 1 to n, that is n network, n port network, Sij into Sij star is equal to 1, unitary property. Next one is the reciprocal networks, summation I equal to 1 to n, Sij, Sijk star is equal to 0. So assessment. Thank you.